Welcome. Today we're talking about finding the area of kites. First, let's review the area formulas that we've talked about so far in this playlist. We started with area of a rectangle, which we know is length times width, or abbreviated as L times W. And there's a little picture of our rectangle with L and W for length and width. Then we talked about area of a parallelogram, and we figured out that was very similar to a rectangle, but we call it base and height. And here's a picture with base and height. But what about other quadrilaterals? We're going to talk about kites today because they have some great symmetry that we can use to easily find the area, specifically by using one of those diagonals. So let's review some of the properties of kites that can help us. This diagonal here actually splits the kite into two congruent triangles, one on the top and one on the bottom. But the diagonals in a kite are perpendicular, so we can actually use that second diagonal to measure the height of each of those congruent triangles. So the height of the top triangle is half of that second diagonal, and then the height of the bottom triangle is the other half. When we look at those two triangles, the base of each triangle is that first diagonal. So it not only helps create the triangles, it gives us a measurement that we can use. And when you think about these diagonal measurements, that's all we need to find the area of those triangles. So we're going to practice one. Let's find the area of this kite that has diagonals length 15 and 8. Now, just a reminder, the area of a triangle, we haven't talked about that yet in this playlist. We have a little more we're going to do with that in a future lesson. But just a refresher from your old math classes, the area of a triangle equals 1/2 base times height. Now I have this notation here where we have A and then the triangle because overall we're looking for area of a kite. So this 1/2 base times height is not going to give us our final answer. This is just a stepping stone. So I'll keep that A triangle to remind us that that's just the triangle. But let's see what we know here. The blue triangle at the top, that's the one we're focusing on right now. So the base of that triangle is 15. That was that long diagonal going across the bottom of it. And we know the height of that triangle is half of the other diagonal, which is 8. So really 1/2 times 8 is just 4. Let's go ahead and plug those numbers into the triangle formula. So area of this triangle is 1/2 times 15 times 4. Now 15 times 4 is 60, and 1/2 times 60 is 30. So the area of that blue triangle is 30. That was only the top triangle. We still need to find the area of the bottom one. Lucky for us, these are congruent triangles, so if we know the area of the top triangle, it's the same at the bottom. Now the total area of the kite, though, we do need to add these up. But 30 plus 30, since it's the same thing as saying 2 times 30. So our total area is 60 square units. Now, we have nice formulas for the other shapes that we've talked about. Let's go ahead and put together a nice formula for kites. So you can just have one formula on your reference sheet and just go for that. So we know we found the area of that kite in our example by using 2 times whatever the area of that top triangle was. And we know the area of a triangle is 1/2 base times height. So let's substitute that in and see what this looks like for a second. So we have 2 times 1/2 base times height. Now that height is the height of the triangle, remember. Now 2 times 1/2 is just 1. We don't need to write a 1 if it's multiplying by things. So really the area of a kite is the base of the triangle times the height of one of the triangles. Now the base of the triangles, though, was our first diagonal. So when we're referencing a kite, instead of having to always go back to the triangles, let's actually reference as parts of kites. So the diagonal is a part of a kite. We don't want to write out first diagonal in a formula, though, so let's abbreviate this to D1. So we'll substitute in. Now we've got area of a kite equals diagonal 1 times h, the height of the triangle. Now again, we don't want to keep referencing back to triangles. So think back to what the height of the triangle represented as part of the kite. It was half of the second diagonal. Now if we use D1 for diagonal 1, let's use D2 for diagonal 2. And let's substitute this in. That'll look like D1 times 1/2 of D2. That's kind of an awkward way to write it, though. Usually if we've got some variables in a formula and some constant numbers, we'll put the constant numbers out first. So it doesn't change the calculation at all, but let's just change the order so it looks a little nicer. This is your formula for area of a kite. So if you're keeping a reference sheet, this is what you want to write down. Let's go ahead and try it with the formula. We won't talk about the triangles so much. We'll just say, what parts of the kite do we have? How did this fit in the formula? So the kite below has diagonals of length 4 and 20. Let's find the area. So here's our formula that we just made. Area of a kite equals 1/2 d1 times d2. Now the d's are just the diagonals, and it told us in the text part of the problem and in the picture that our diagonals are 4 and 20. So let's go ahead and plug those in. So we have area equals 1/2 times 4 times 20. Now it doesn't actually matter which one is diagonal 1 and which one's diagonal 2. We could write this as 1/2 times 20 times 4. We're going to get the same answer either way. Let's go ahead and multiply these then. 1/2 times 20 gives us 10, and then 10 times 4 gives us 40. So our final answer then is 40 square units. Now let's try this backwards. What if we know the area of the kite and we know one of the diagonals, but we need the second one? The kite below has an area of 320 square units, and one of the diagonals is 10 units long. Now we don't actually know if it's that little diagonal, the short one that measures the height of the triangles, or if it's the bigger diagonal that gives us the base of the triangles. Lucky for us, we're not referencing the triangles anymore. We're just looking at diagonals. And since it doesn't matter which diagonal is D1 and which one is D2, we can just use the 10 and it doesn't actually matter. So we know the first diagonal, because that's the one we know, is 10, and we know the area is 320. So let's fill these numbers in where they go in the formula. 320 for the area equals 1/2 times D1, which is 10, times D2. Now 1/2 times 10 is 5. And then we got to use our algebra skills here, so we'll divide both sides by 5, and we'll get 64 equals D2. So our final answer there is 64 units for D squared. But if we think back to our little problem of which diagonal was the 10 and which one is the one we're looking for, since we have 10 and 64, based on this picture, it looks like 10 is the tall one that's a little bit shorter, and then the 64 would be the longer one. But like I said, it doesn't matter when you're finding the area. If we were doing other things with the kite, we might have to pay more attention to that. But since our formula is just multiplying the two numbers, you can multiply in any order. So that's all I have for you about finding area of kites. Thank you so much for joining me, and I will see you next time.